Hello everyone. Now that you've learned about inverse trigonometric functions, you're ready to begin to learn about compositions. This can be found on page 345 in your textbook. So get there now so you can follow along with me. So on the top of the page, you're going to see these two properties. These two properties you learned about in Algebra 2, and you also learned about this in section 1.9 this year. So the first property tells you that when you take a function and inside of this function you replace its inverse, you will result in x. Okay? And if you do it the other way around, you will also result in x. So how does this help us now? So let's start with sine, because sine was the first inverse function you learned. So what this property tells us is if you take the sine function and you replace its inverse, you will result in x. And if we do it the other way around, we will also result in x, right? You would hope it would be that simple, but unfortunately it's not, because this is trigonometry, of course. So key advice here, always know what range you're dealing with. So if you look on page 345, they pretty much give you a summary of each inverse function. Sine and tangent are the same as far as range goes, and cosine is the only different one. I always also think of it as quadrants, if that helps. I know that sine and tan are in quadrants 1 and 4, the inverse I mean, and cosine is in 1 and 2. But with sine and tan, we got to be careful because it's not our usual quadrant 4 values. It's only, it's going clockwise, negative pi over 2, right? And counterclockwise to pi over 2. So only values for sine and arctan, we can only have values between negative pi over 2 and pi over 2, whereas cosine is from 0 to pi. Okay, so we have to be super careful that the value given is a value within this range. So for example, on page 345, you'll see example 5b. Okay, notice it says arc sine of 5 pi over 3. So the property tells us that we have a composition, so the answer should be 5 pi over 3. You will be very wrong if you say the answer is 5 pi over 3. Definitely not it. And again, it's from what I just said. Look at your range values. Negative pi over 2 to pi over 2. This is definitely not a number within that range. So the first thing to do is to figure out how we can get this, and can we get this to be a value within that range? Yes. Okay, we know, well, hopefully you know that 5 pi over 3 is located here, quadrant 4. So if we find its coterminal angle, then we can find a value within the range. So knowing your skills from earlier in chapter 4, you know that in order to find coterminal, and we're going to subtract 2 pi because it wouldn't make sense to add 2 pi, because then we would be going even further outside of the range. So we're going to subtract an entire rotation and see if we can get a value within that range. And indeed we can. Negative pi over 3 is a value within that range. So now we can rewrite this problem right to be negative, because we have now found, okay, now we have found a value within the range, and so now we can apply the property. Now the answer is negative pi over 3. Ta-da! Okay, using the inverse property. Now I'm going to show you another way you could have done this problem, which may make a little bit more sense to you. Instead of using the property, you can use information that you already know without even knowing this property. So let me rewrite the problem. Okay, so think of always like order of operations. I don't know why this keeps happening, so I'm going to have to start a new page. So let me rewrite the problem again. My iPad is low on battery, so it's acting up. Story of my life. I never charge things. Okay. So PEMDAS, right? Order of operations. So I'm going to do the parentheses first. So I'm going to figure out what is sine of 5 pi over 3. And again, we already located it. 5 pi over 3 is here. So what value? Well, we know that this is 1/2 comma negative square root of 3 over 2. And if we're dealing with sine, then we know that that's y. So this is negative square root of 3 over 2. And so now we have to find the arc sine of negative square root of 3 over 2, meaning what is the value? What is the value of the angle? What is the value of the angle whose sine is negative radical 3 over 2? What's the angle whose sine is negative radical 3 over 2? But be careful, again, has to be within the range. Again, the answer is not 5 pi over 3, it's negative pi over 3, because that is an angle whose sine is negative square root of 3 over 2 within the range. Okay, so always be careful that it's within the range. Got it? Okay. Now, let me show you what else we can do with compositions. So besides using the properties, we can also evaluate compositions. Evaluating. This can be found on page 346, and this will be my last example for this video. I'm going to be using example 6b. So example 6b says cosine bracket arc sine of negative 3 over 5. Okay? Now the first thing that you'll notice is that we can't apply any property here because we don't have inverse here. We have totally different function out here and a totally different inverse in here. So what you have to, again, always understand, what does this mean, the inside? What does this mean? It means the angle whose sine is negative 3 over 5. The angle whose sine is negative 3 over 5. And it has to be within quadrant 1 or 4. And since it's negative, it's going to be in quadrant 4. So we know that sine is equal to opposite over hypotenuse, right? So we're going to use the fourth quadrant here to draw an angle whose sine is negative 3 over 5. Okay, so we're going to draw in an opposite and a hypotenuse. And again, it can't be in quadrant 1 because quadrant 1 is positive, and this is showing us a negative value. So using our good old friend, the Pythagorean theorem, we can do negative 3 squared plus b squared equals to 5 squared. And when we solve that all out, subtracting to both sides, square root, saving some steps here so my iPad doesn't die, we get b to be 4, okay? And that is now our adjacent. So we have one last step to do, is to find the cosine, okay? So what does cosine equal? It equals adjacent over hypotenuse. And we have now found the adjacent side, which is 4, and the hypotenuse, which is 5, and that's it. There is our answer. Okay? I hope this video, I hope you learned some things, and I will talk to you guys after the spring break. I hope you all enjoy and stay safe. Okay? Bye-bye.